Okay, to start off, we're going to do an example using our conversion factors. So I'm going to introduce a new idea today. This idea is called something called a half-life. So let's start off by just briefly talking about what that is. So half-life, we are very lucky in that half-life is actually something that sounds a lot like what it actually is. So half means just like your whatever you usually think of when you think of half. So for example, if you have a pizza, this is my drawing of a pizza. Let's make it a pepperoni pizza. So this would be the whole pizza. And if I was talking about a half pizza, it would just be that thing divided by two, right? Or cut into half. So it would look something like this. This would be my half pizza, right? I'll draw like a dotted line to show like this is the rest of the pizza that's missing. And this is a very ugly drawing. It's not exactly half of my drawing, but just imagine that there's exactly half of it left. And so one thing that's kind of interesting about this idea of a half-life is it actually describes how certain elements, and we'll talk more about exactly what makes something an element. But for now, let's just say a thing. Certain things will actually change into something else. And you can measure how fast they do that by this half-life. So let's just for fun, let's imagine that we're talking about a pizza and it just changes into something totally different. Let's say it changes into like jello. And so here we'll have half of a pizza and the rest of it, let's make it that the rest of it has turned into jello. I'm going to, does this look like jello? I put it maybe like wavy there. So it's like wobbly jello. And that's what it turns into. And the half life just tells us how long it takes to turn into for half of it to turn into that other thing, in this case, jello. And so the cool thing is like from from here, from our first pizza, and just imagine that this is time passing to here, that's one half life. One half life. That's what half life means. It means the time it takes for this thing to turn into something else and for only half of it to be left. That's what one half life means. And so if we measured another half life, let's do another half life here, the same amount of time. So another half life, one half life. Now, by the time we get here, what happens is half of the pizza that we have left has turned into jello as well. So now, of the pizza that we have left, half of it is going to turn into jello. And so that'll look something like this. I'm going to make sort of like a pizza pie slice that looks like this. And the rest of my used to be pizza has now turned into jello. And you might be thinking, what in the world are we talking about pizza and jello for? But the really amazing thing is that actually, when we're looking at how some of these elements are transforming to other elements, it's kind of this miraculous. Like it's kind of this unbelievable that you get these things that turn into something totally, totally different. And so let's now just keep going just for fun and say, okay, what if we took another half life? So let me get another half life. It should be about the same. It's the same exact length of time. So some more time has passed. Let me do this too, so this is clear. Let me put time and an arrow this way to show that time is passing, right? So going from here to here, time is passing. And so again, another half life, one more half life. We would have whatever pizza existed at this moment, one half life from then, there's going to be half of that pizza. So let me see if I can even draw that. It's probably going to be a little challenging and definitely ugly, but hey, I'm not an artist, I'm a chemist. Okay, so there's the pizza that's left, and the rest of the used to be pizza is all jello. And one thing to point out here that I'm sure you have probably realized is not all things really do this, right? Like it's certain things that have a tendency to change from one thing to another. Most things that we interact with in our lives don't behave like this. This is kind of amazing, right? If pizza turned into Jello, it would be a disappointing world unless you're a huge fan of Jello. but I'm just using this so that you can get a sort of a picture in your mind of what exactly it means for something to be a half-life. And so let's now do an example. So let's say that we have a problem. I'm going to just block this off here so that we know, yep, this is our discussion about a half-life, so that we have at least some kind of idea about what Adriana's talking about with this example. So let's say that a problem tells you, hey, this thing, we're going to call it thing 212 to give it an ominous name. I'm making this up. Okay, I'm making this up. I'm just calling it like thing 212, like experiment 212, or what's that? I know, like Stitch, Lilo and Stitch. He was like experiment 266 or something. So I'm just calling this thing 212. It's a thing. We don't know exactly what it is right now, but we're going to call it thing 12. And the problem says thing 12 has a half-life of 30 years. So what does that mean? It means that if thing 212 was a pizza, in 30 years, if we didn't do anything to that pizza, we just left it there. I mean, apart from it rotting, but let's pretend that thing 212 doesn't rot. In 30 years, it would have half of it would have turned into something else. In our example, would have turned into Jello, but that's a very unlikely conversion to happen. But let's just say that that's what it is. And so thing 212 has a half-life of 30 years. So in 30 years, whatever we had of thing 212, there's going to be half of it. Okay? So the first thing we need to do is we're going to write an equality from this statement. We're going to write an equality from this statement. I'm going to give you a moment and just think, what equality could we write from this statement? So I'm going to tell you the answer. Hopefully you took a moment and tried to think of it and see if you could come up with it yourself. So in this case, we're going to write an equality of this. One half-life equals what? 30 years. 30 years. And if you're thinking like, oh my gosh, can I do that? Can I just write an equality? Yes, you can, because I'm telling you, right? I actually gave you this equality. I gave it to you right here. But you're going to write it into our familiar form, which is as an equality like this. And so I'm sure we can very quickly now write two conversion factors to use with this equality. So let's just do that now. One half-life. That's not what I meant to write. One half-life divided by 30 years equals 1. And then we can do the same thing, but flip it. So we can do 30 years divided by 1 half-life. So now we have two conversion factors, which is lucky because I'm going to give you the rest of the problem now. Okay, so I went ahead and just did this. The rest of the problem is this. If, let's say this, in 90 years, how many half-lives have passed? That's the question. So let's set up our problem. The first thing we do when we're doing a dimensional analysis problem is we use what we are given. We're given 90 years. So let's start our problem over here. So we're going to write 90 years. And remember how I told you that it's just way, way, way easier if we can turn things into a fraction? Let's do that now. How do we turn it into a fraction? We just divide by 1. Remember that this line, you can say divided by, then you put the number 1 on the bottom. Boom, we did that. Okay, now we need to multiply this by a conversion factor, right? We're multiplying it by 1, which we're allowed to do as many times as we want, but we're just going to write 1 using one of these conversion factors as usual. So which of these conversion factors would allow us to get rid of years? Because the question is not asking about years. What does the question want? The question wants to know how many half-lives. So we're not done until we have units of half-lives. Right now, our units are years. That's not right. We don't want that. And so we need to get rid of years. And so There's only one option that would allow us to do this. It's this conversion factor right here, because here we have years in the numerator. We need the conversion factor with years in the denominator. So let's do that. 1 half-life divided by 30 years. And so let's go ahead and cancel out whatever we can as we go, like we have done in our previous examples. So we can cancel out years, right? Thankfully, we can cancel out years. And so now we should feel pretty happy because check out the only unit that we have left. It's half-lives. That's what we want. So let's go ahead and multiply through. So in the top, the only thing that's left is a 90. 90 multiplied by a 1 multiplied by half-life. And in the bottom, our denominator, we have 1 multiplied by a 30. Let's keep going. Let's keep multiplying. And so here, 90 times 1 is 90. 90 half-lives. Half-lives. And in the bottom, we have 1 times 30, which is 30. And we are almost done here. We are almost done here. The only thing we need to do now is simplify this as much as possible. When you look at this answer, you're probably going, okay, well, how much time is 90 over 30 half-lives? So let's actually do 90 divided by 30. So I'm going to just ask my friend the calculator. Now, we could do this in our heads, right? There's never anything wrong with doing it in your head. I just want to empower you that if you are nervous about doing mental math, right now, that is not what I'm assessing. I'm not assessing if you can do mental math right now. I am assessing whether or not you can understand how to do these problems. And so I'm just going to encourage you to don't even worry about the mental math for a moment and just let's plug in 90 divided by 30. 90 divided by 30. And what we see is the number 3. That's our answer. So let's go back here and plug that in. And so we have, that is equal to 3 half-lives. 3 half-lives. Now, if all of this makes sense to you, great. If you're here wondering, wait a second now, why is half-lives not in the numerator anymore? It is in the numerator. Remember that this can also be written like this, divided by 1, right? You could take anything and divide it by 1, it's still equal to itself. So I'm just mentally doing that step, but let's do this if it makes you feel better. If we do 90 divided by 30 and we have 3, we can leave that like that and then just confirm to ourselves, yeah, that's the same as saying 3 half-lives. 3 half-lives. Okay, now let's take this one little step further, okay? Let's say that I say, hey, at the beginning of that time frame, so, at the very, very beginning of those 90 years, how much did we actually have of thing 212? And so let's just say in this example that if you had 1.0 milligrams of thing 212, thing 212 at the beginning of those 90 years, how much would be left by the end of 90 years? So I want to just see if we can just envision that for a moment here. So again, let's just imagine that we started off with our pizza. After the first half-life, we would have had half of that pizza. After the second half-life, we would have had 1/4 of that pizza. Do you see that, right? So we had a whole one. After one half-life, we only had half. And so after another half-life, we only had half of that half, which is 1/4. And then after a third half-life, we would have half of the half, which is 25, which is a quarter, which is 25% divided by 2. So it should be 12.5%. So if this is confusing to you, we're going to go over that more. But I just wanted us to sort of visualize what that really means. So 3 half-lives later, how much would we actually have? So I'm going to pull out my calculator here, and I'll show you one way to do it. There are several ways to calculate that, but let's just do this way now. So we started off with 1 milligram. In one of those half-lives, in one of the 3 half-lives, which we calculated, half of 1 milligram would be this. So let's type in 1.0, and we're going to divide it by 2, right? That's what it means to have half of something. So put divided by 2, and that is 0.5. If you see this answer here, it just says 0.5. That's the same as 0.5. So let's actually come in here and write down what we just did. So let's just put at the start, we have 1.0 milligrams. So 1 half-life later. So let's just put 1 half-life. We have 0.5 milligrams of thing 212. Let's go another half-life now. Okay, so 1 more half-life. How many do we need? We need 3. That's what we calculated. We calculated that after 90 years, that's 3 half-lives. Okay, so let's see what happens. We're going to do this now and divide that by 2, because here we need to do half. We need to get half of this half. So let's go back and say, all right, let's take our 0.5 and divide that by 2. So our answer is now 0.25. So let's write that down. 0.25 milligrams. So we've had 1 half-life, 2 half-lives, and we just need 1 more to find our answer. So we're going to go 1 more time. There's another half-life. 1 half-life. And so now we just need to do our final calculation, which would be 0.25 milligrams divided by 2. Let's do that now. 0.25 divided by 2. And the answer is 0.125. Let's write that. 0.125. Am I done? No, of course you're not done. Where are your units? 0.125 what? Puppies? No, you need to write your units. Milligrams. And so this is actually our final answer. Our original question was how many half-lives have passed? And our final question asking like, okay, so if you had 1 milligram at the beginning of that 90 years, how many would you have by the end of the 90 years? And we used our knowledge of half-lives to calculate that. So the answer is 0.15 milligrams. I should actually, it would be even better if I did it like this. 1.25 milligrams of thing 212. Okay, so let's put a box around all of that, and we are done with this example.